laws of exponents apply to algebraic expressions. Leon's math teacher asks him to write an expression equivalent to the quantity 4 times x squared times y squared, all to the power of 3. How can he write an equivalent expression? A monomial expression consists of a real number, a variable, or a product of a real number and one or more variables. Which expression is a monomial?
Select your answer.
One way to write an equivalent expression is to write the algebraic expression in expanded form. Write 4 times x squared times y squared multiplied 3 times. Write each factor in expanded form. Group like terms together. Multiply the coefficients. And rewrite the variables using exponents. Another way to write an equivalent expression is to use the laws of exponents. The variables of an algebraic expression represent numbers, so you can use the laws of exponents. Apply the power of a product law. Simplify the powers that use numbers. Apply the power of a power law. Then simplify the expression.
Apply the laws of exponents to write equivalent algebraic expressions.
For the first expression, we have 27a to the third power times b to the third power. So we have to expand that. So we're going to do 3a, and then we have to represent the b. So we have b to the third power, and that third power is outside of the parentheses. So that would be that, and just to show you what that looks like written out, 3ab times 3ab times 3ab, and then this is the full expanded, and then it will simplify to this. But this is how it could start, and then you could do this, and then you could put all the 3's together, all the a's and b's, and then that's how you get this. All right, the next one, 1/2 times y to the 6th power equals 1/2 times y to the 2nd power times 1/2 y to the 4th power. Because remember, one of the laws is that when you're multiplying the exponents, you just add them together. So 4 and 2 would equal that 6. C, we have 25 m times 10 n times 14 equals 5 m blank, and n times blank squared is on the outside of that parentheses. So when you have the exponent on the outside, your exponents on the inside of the parentheses, one of the laws is multiplying the exponent inside and the exponent outside. So 5m to get to the 10th power, I need this number to be a 5, because 5 times 2 is 10, and then my n to get to 14, I need that to be a 7. So 7 to the power of 2, and you would multiply and get that 14.
Apply laws of exponents to write equivalent algebraic expressions. Part A. 3/4 times y cubed times 2/3 times y to the 4th power.
All right, so they break it down here, where you put your fractions together, then you get your y's together, and then you simplify and use the product of powers law. So we have to add the exponents here for the y, and then you evaluate the 3/4 and 2/3. For b, we have this expression, and we break it down this way. So you have the 5 being broken down cube, the a being broken down to the cube, and b -3 exponent cubed, and then you evaluate. So that's negative 125, and then you multiply the exponents here, and then you multiply the exponents here, and it stays negative because you know negative times a positive is still negative. And then because it's negative, you need to divide to, so you have the negative 125a to the 6th power over the b to the negative 9.
Apply laws of exponents to write equivalent algebraic expressions. Part A. X squared times y cubed divided by x times y to the 4th power.
All right, so we're breaking it down. You are subtracting the exponents here for the x's. So 2, when you're dividing, you're subtracting. So 2 minus 1, and then 3 minus 4. So that gives us positive 1. This gives us negative 1. And then we have the identity exponent law, where the exponent is 1, it's itself, and then the negative exponent law. So because that's a negative exponent, we have to show the division. So you have x over y. For b, you have negative 9c over d, and the exponent of 2 is on the outside. We break this down. You see negative 9 to the power of 2, c to the power of 2, and then over d to the power of 2. And then you have negative 9. Negative 9 is 81. And then you have your c squared and d squared. And then there's no like terms here, so that's your final answer.
Apply laws of exponents to write an equivalent algebraic expression for x to the 0 power times y cubed times y.
All right, so we're going to use the 0 exponent law, where if the exponent is 0, it equals 1. So x now is 1, and then you rewrite the rest of the expression. Now you use the identity exponent law, so that y is single, so you have the exponent of 1, so that now you add the 3 and the 1 because that's the product powers of law. So now your evaluated expression here would be y to the power of 4. Okay.
Write equivalent algebraic expressions using the laws of exponents.
We have the quantity of v times w squared over v cubed times w, and the exponent on the outside is 4. So I'm going to break this down this way. We're going to have v to the 4th power, and we have w squared. And now I'm not going to do that. We know that because it's on the outside of the parentheses, I can multiply these two. So I'm going to just make that w to the 8th power over v cubed. Again, we have the 4 on the outside, so we multiply those. It'll be v to the 12th power. And then we have w to the 4th power. So now the next step would be to simplify or to combine like terms in a sense. So because it's division, we are going to be subtracting these exponents. So 4 minus 12, I'm going to write it underneath 4 minus 12 for v, 8, and w, 8 minus 4 is 4. So our final answer would be, I didn't write that correctly. Let me erase. Sorry. We're going to have the w on top because that's 8 minus 4 is a positive. Well, the 8 is bigger, so it's going to stay on the top. So w to the 4th power at the top, and then v will be the denominator at, what did I say, 8. So that would be your final answer for A. Now I'm going to move to C, just to stay on this side. So I have a to the 5th power times a times b to the power of 0. Well, we know if the exponent is 0, that the number becomes a 1. So now this looks like this, 8 to the 5th power times a times 1. And then we're going to combine like terms, so the a to the 5th power and the a will be essentially to the power of 1. So we would add those exponents together. So now it comes to the final answer of a to the 6th power. Now let's look at b. A to the 5th power times a, b to the power of 0. So again, we know to the power of 0 makes it 1. So we're going to have a to the 5th power times a times 1. And then a by itself as an exponent of 1. And we are going to add the a's because those are our like terms. So it'll be a to the 6th power. It's the same question. I think that was an error. Anyway, let's move on to D. Now we have in parentheses 3 times j to negative 1 times k to the power of 8. And outside of the parentheses is the exponent of 2. So now I'm going to rewrite this as, I'm going to expand it. So 3 to the power of 2. That j is going to go on the bottom because of the negative exponent. So we're going to show it as division. And so again, when you have the outside exponent, you multiply the exponent on the inside and the outside one. So that becomes j squared. And then you have k, and then 8 times 2 is 16. So our final answer, oh no, not a final answer yet, because I did not evaluate the 3 squared. So 3 squared becomes 9 times k to the 16th power over j squared. That will be the final answer for D.